So hello, good morning, everyone, and welcome. I'm Jared Torgerson with PureLine. Thank you for joining PureLine Solutions Food Safety Roundtable series. The topic today is going to be combating Cronobacter, or Cronobacter. You had me saying it. Anyway, I'm very excited to be joined with Martin Wiedmann, PhD, and at the Gellert Family Professor of Food Safety at Cornell University. We got Joe Stout, founder of Commercial Food Sanitation, a 30-year veteran at Craft Foods. We have Monty Bohanan, Associate Director of Quality and Sanitation at Leprino Foods. Let's go through the agenda here. We're going to be Cronobacter 101, zoning and floors. So Martin will be doing Cronobacter 101. Zoning and floors is going to be done by Joe Stout. Environmental monitoring and dry sanitation by Monty Bohanan. Before I turn it over to Martin, I wanted to briefly introduce PureLine. PureLine specializes in chlorine dioxide decontamination and environmental resets. PureLine offers both gaseous treatments as well as liquid CLO treatments for floors, drains, and various water treatment applications. One other thing just to mention before we get started, if you have any questions during the presentation, please click on the Q&A, write your questions there, and we'll answer them at the end. So with that, I'm going to turn it over to Martin, and we can get started.
Great, thank you, Jared, and welcome everyone. So I'm going to warm us up with a little bit of background on Cronobacter. Next slide, please. And then I'm also going to talk a little bit about the role of WGS in detecting Cronobacter, outbreaks, tracing them back to source, and what the current picture is. A lot of us are used to application of Cronobacter to Listeria and Salmonella, but the picture is a little bit different in Cronobacter. So here's background on Cronobacter. Cronobacter species, and that is sometimes a cause for confusion, was formerly known as a single species, Enterobacter sarcosarchii. What used to be Enterobacter sarcosarchii is now multiple species. They belong to the family of Enterobacteriaceae, which is important because testing for Enterobacteriaceae, or EB, is an important part of an environmental monitoring program, I'm sure Monty will talk about, in order to identify locations and conditions where Cronobacter may be present, may survive, and may cause us issues. So what used to be ESAC, or Enterobacter sarcosarchii, now is Cronobacter sarcosarchii, Cronobacter myelonaticus, Cronobacter turicensis, and a number of other species. Only 3 of them cause most of the issues, cause most of the foodborne illness, the first 3, but in terms of regulations and environmental monitoring, we're really looking at all Cronobacter species. Next slide. This just illustrates this in terms of sort of a family tree. You see on the top, Cronobacter, the genus Cronobacter with the different species. And you can see that these are closely related on this family tree to different Enterobacteriaceae. Important point that's made on this slide that sometimes these close related organisms could be misidentified. So sometimes some of these Enterobacteriaceae could be misidentified as Cronobacter. I'm pointing this out because to remind everyone, it's important to have a good lab that has experience with Enterobacter sarcosarchii and with Cronobacter when you do testing. Next slide. Also a reminder, just the route of contaminations. Obviously, what's probably on everyone's mind here today is contamination of dairy powders, or maybe even other infant formula type products from the facility. But when we look at the disease cases, the disease outbreaks, very often these are caused by contamination that occurs at home during preparation. So, but that doesn't mean I don't mean to distract and say that control in the facility is not important, but it is important to remember that this contamination can occur throughout the system. Next slide. So these are the kinds of illnesses that Cronobacter causes. The major concern is obviously the disease it causes in infants, 12 months and younger, and often substantially younger, where it can cause sepsis, so bloodstream infection and meningitis, essentially brain infection. This is the major concern because 40% of people with meningitis die, with Cronobacter meningitis die. We often talk about Listeria monocytogenes being the most severe of foodborne pathogens. If you measure severity as the percent of people with the disease that die, Cronobacter is actually worse than that. In addition, and this is important to keep in mind, there have been some reports of bloodstream infections due to Cronobacter in people with weakened immune systems, HIV, organ transplants, and older people. We typically consider Cronobacter as an opportunistic pathogen that only needs to be controlled in food for infants and infant formula. But I wouldn't be surprised if some of you at some point might be in a situation where, due to some wrong turn of events, you have a lab results that now says you have Cronobacter in a finished product that is not intended for infants. And then you need to decide, what are you going to do in this case? Okay. Particularly if you were to know that some of these products may even go to consumers that fall into that second category where some of these bloodstream infections have been known. I hope it doesn't happen, but I think if I were in industry, I would want to think through it and want to make sure that no one by mistake decides to do some characterization of EB isolates from finished product or a food contact surface even, for that matter. Next slide. Some more details on just the impact. This is from CDC, and it illustrates, 40% of people with Cronobacter die, just what we said. And the last sentence is important. Infant formula contamination, most commonly from opened containers, was identified in 30% of investigations. So it's infant formula in essentially all cases, but it can be caused by contamination at home. Now, one of the main reasons we're here is obviously this outbreak. And let's dig into that one a little bit deeper. Next slide. So here is when you sort of go down and look a little bit in that report, there's some things that some of you may find interesting. First of all is whole genome sequencing of Cronobacter was performed on isolates from 2 patient samples, not all 4. And that will be important, and I'll get back to that. The other thing is interesting is that WGS did not, and I emphasize not, find these samples from patients to be closely related to the multiple strains of Cronobacter found in environmental samples. So if you use Listeria or other foodborne pathogens, like what's going on here? Usually it's like we have an outbreak, we have multiple cases, same Listeria whole genome sequence, and to find that same subtype in product or in environment. Here they didn't. So the playbook is a little bit different with Cronobacter, partially because of the severity of the disease, partially because of the fact that it is only transmitted through one type of product, and then many infants who get the disease really just consume that one type of product. So while whole genome sequencing was used in this case, it is not the evidence that definitively linked Cronobacter in the patients to this facility. Next slide. Now let's dig a little bit deeper into what is in this whole genome sequence database. And that will help us probably also explain some of these findings. So if we compare the whole genome sequence database that's publicly available to anyone to call, as long as you know how to get there and look at the information, you can find the same information I'm showing you here, and I will show you. That database almost has 500,000 whole genome sequences, so essentially DNA fingerprints of Salmonella in it. More than 50,000 Listeria. Cronobacter, 1,000. So much smaller number of whole genome sequencing. Partially not that surprising because we only see about 4 to 6 reported cases a year in the US. So next slide. So where do those isolates come from? This is just a simple search there. You see on the top, you look at Cronobacter and say where they came from. Most isolates from the US, followed by China and Germany. Then if you look the states within the US, second most common state, surprise, surprise, Michigan. All right. Now that we have this, let's see what we can find there when we take a look at these Michigan isolates. Next slide. And I'm not going to show you all, but I'm showing you 2 clusters. So these are groups of closely related isolates that have a lot of these Michigan isolates in there that appear to be linked to this outbreak. So if you look at the top one, you see in this family tree All of them say US, Michigan, environmental swab sponge. You can see in the middle there, where I highlighted one date, that they were obtained from FDA, a couple of FDA samples in there. Other isolates were obtained from something called OSF. You can see dates. There are actually 2 dates. There's a date further on the left side. That is actually when these sequence data were uploaded in the database. The dates are highlighted, where I highlighted a few of them, are the dates when a sample was collected. Something interesting you see here is that this positive samples, so the sample collection dates, appear to range from February 1 through actually June 10. So it's over a decent time frame, which someone just looking at that, and I really have no insider information, and said, that looks almost like this Cronobacter may have survived in a facility over time, at least 4 months. On the bottom, you see another sample. There we have isolates that were all collected on June 10. They're all very, very similar to each other. From these data, we can't derive whether they were multiple samples or whether they were all obtained from the same sponge. And OSF decided to sequence multiple isolates that were obtained from the same sponge. But these data are now in the database. Interestingly enough, no human isolates in either of these groups, which is what you would typically find if you look at a Listeria or Salmonella outbreak. Consistent with what I showed you in one of the previous slides is that there was no match by whole genome sequencing. But of course, now that these data are in there, if there are any future cases that were to be matched these cases, then there would be strong evidence that they may have come from the same facility. So here's where we will see a similar pattern of what we see with Listeria. FDA and others are building databases that has the unique Cronobacter fingerprints isolated from different facilities, which will enhance most likely the ability to link infant illnesses with Cronobacter to different facilities, which is why what we will hear in the next two talks is so important to proactively address this issue. Next slide. This is going to become even more interesting because of this. Stop Foodborne Illness, public interest group, already posted a letter to a public health official saying that to make Cronobacter illnesses reportable. What does this mean? Right now, there's only one state in the union where if a lab or a hospital identifies a patient with Cronobacter, that has to be reported to the state or to the CDC. This is very different from Listeria, where essentially infections have to be reported in all states. It's a reportable disease. What does that mean? The disease is reported, the isolate's more likely to be sent to a state health department, it's more likely to be subtyped by whole genome sequencing, it's more likely to be linked to a source. Cronobacter is not reportable except for Minnesota, which most likely is why we only have WGS data for 2 of those 4 isolates. If this changes, then we have the other side of this equation. We will have more isolates from processing facilities, we have more isolates from human cases, and we can link them through whole genome sequencing. My prediction is in the next 2-3 years, we're going to have that in place, and we're going to more likely detect sources or putative sources of a lot more Cronobacter infections than in the past. Again, industry has a finite window to after that and really enhance their controls for Cronobacter. And I'm not implying people don't do it already before this happens. Next slide. So take-home messages with this. Cronobacter is an organism that not that many people work with. Make sure you use the right labs, have the right experts. I predict a high likelihood that Cronobacter will become more of a focus of regulatory and food safety agencies. That's not a big lift to come up with that. But I also think what many people don't appreciate is how much WGS of Cronobacter is at its infancy and what will happen when we have better implementation and penetration of WGS for Cronobacter. I also predict that we will see similar pictures to what we see in Listeria and Salmonella. If you have evidence that the same Cronobacter is found in the same facility over time, that someone is going to be the FDA in the US, is going to conclude that this infant formula was produced under insanitary conditions. And if a food is produced under insanitary conditions, it's considered adulterated, and that means it has to be recalled, even if there's no evidence of a finished product positive, even if there's no evidence of a human disease case. If you're interested more into that sort of WGS meets regulations, we just published an article in the Food Safety magazine. Shameless plug for it. Take a look at that. It gives you some more details on how that works and how the intersection between legal and WGS. So I hope I set up our next two speakers in terms of why this is really important, not beyond just what meets the obvious, that we had an outbreak with a lot of publicity, but I think it will lead to a lot of other changes that makes attention to this pathogen in a variety of industries a higher priority. Thank you very much, and I'm happy to turn it over to the next person.
Thanks, Martin. Go ahead, Joe.
Thanks, Jared and Martin and Monty. Martin, it's a very sobering presentation that you made, and I think it just points to how can we better control the environments and the equipment in a food plant to minimize the risk to consumers. Over the years, I've been working with PureLine probably for 15 years now, since I was at Kraft, and we did some pilot work with them. And since then have used chlorine dioxide in many applications, from bakery to freezers to dairy plants, etc., with some good results. Next slide, please. So there's a lot of dairy pathogens of concern, but today just focus on Cronobacter, as Martin indicated. But there's a whole plethora of different challenges that the dairy industry faces. And many of the controls that we'll talk about here apply to Salmonella, for example, and to other organisms as well, especially in low moisture environments. Next slide. One of the things that I've been fortunate to be involved in is Dairy Management, Inc. And we at the Innovation Center, actually I was a facilitator for the team, and we did dairy food safety training for probably 6 years. It's still going on. I no longer lead that. But one thing we did do at the request of John Sheehan at FDA was put together a manual for pathogen control in dairy processing environments. And this not only covers Listeria, but it also covers Salmonella, it covers Cronobacter. So it's a broad approach to how we can control the pathogens in the previous slide in a dairy plant. This is available online if you want to do a search. Just look for Dairy Management, Inc., pathogen control, and it pops up. Next slide. And part of that and the way we organized the document was to use the Listeria equation or pathogen equation. Initially, when I created it, we just used it for Listeria, but it works for just about everything. And we use this at Kraft for years, and it's used in dairy, it's used in meat. But it's there is a lot of things that need to be done in order to control pathogens in an environment. And this is a guide under each of these principles. You can have different control points that need to be followed. Wanted to talk about two really today. One is separation of raw from ready to eat, which we call zoning, and also sanitary design and facility equipment design. And part of that discussion, again, is floors. Okay, next slide, please. So first talk about hygienic zoning. And there are really 4 levels. Once you break past the raw, we start from the bottom and go up. So we have raw, we have low care, which is essentially warehousing and receiving. We have medium, non-ready to eat, and basic GMPs. And then there's high ready to eat, and then there's high hygiene extra care, and that's when you have open product and exposed to the environment with no subsequent kill step. And this, by the way, is in that guidance document. So you can, I'd encourage everyone who has an interest in this area to take a look at it. Next slide, please. I also do a lot of work in the produce industry. And this just shows a simple layout, but it illustrates the principles really good. So if you start on the left side, you have raw receiving, then you have a ready-to-eat area where everything in that room should be equivalent to what is in a high hygiene area, meaning no pallets, the right GMP garb, the right protection, the right cleaning techniques. And then you have a wash flume where the produce is washed and sanitized, and then it moves on to the high hygiene area. In the high hygiene area, that's the same as we talked about in the dairy industry, but it's a little simpler to follow. I have another chart of a dairy plant, next slide, please, that shows a little more confusion, but in a dairy plant, a lot of things are in pipes and it's moved around in a different way, but still you need good separation to ensure that you don't have cross-contamination. And the best thing you can think about is in a cheese or meat plant, everything is pasteurized in today's world. And why would I find pathogens in pasteurized product, right? Well, it's cross-contamination that occurs somewhere along the way post-pasteurization. And that's what we need to focus on, is ensuring that we minimize cross-contamination potential. And that really is the worst case, is raw into a high hygiene area. Next slide, please. This is a schematic also from the manual. And you can see even with airflow, you need to move from high, that airflow direction, positive to negative, needs to go from high to ready to eat to raw to general. And our goal here, again, is to minimize cross-contamination to the most sensitive areas of the plant. And that's everything falls in behind that. Next slide, please. So this maintenance room opens into a high hygiene designated area. And so when you look at this, and you have to look and think proactively and creatively as you look at a door like this, but I went into this plant. This was not a dairy plant, it was a produce plant. But as you can see, as that maintenance person would leave the maintenance shop, which this is a picture of, and go into that high hygiene area, he's slamming the door behind him. And the only thing I can think is his hands must not be clean in order to leave that kind of soil on the door. So every time you go through, he closed the door behind him. And that's how we need to think about everything that goes into that high hygiene area. We need to be perfect in our approaches and really deliberate and constant about vigilance to do the right thing. Next slide. So let's talk about floors for a minute. And INJFS, and that says, you know, it's not just the floors, Sam. Some other people might say something different. It's not just the floors, something, but we have to think of floors as an entity, but it's all about those things that contribute to soil on the floors. Frequency of irrigation. I think of water in an environment. I mean, in a food plant, our floor should be dry, especially in a dairy plant where we deal with dry products because of the risk to low moisture foods that moisture brings. But when we clean and we introduce water, it's like irrigating a farm field. You're going to get growth. Feeding the masses the same way. What is falling from the overheads onto that floor? That's going to cause the problem. The floor may be by itself cleanable, but if you continually litter it with water and food, you're going to have a problem. The shelter for homeless. Bacteria are homeless unless they find a niche in the plant, whether it's a hole in the floor or a sandwich joint. We need to make sure that we eliminate those homes and make them homeless and no shelter. Protect the borders, that's another way to zone. Keep the bad bugs and bad things out of a sensitive area in the high hygiene area. Daycare for the offspring. If they do multiply in the plant, you don't want to continue to provide services for the offspring of the bacteria as they divide in 2 and then to 4 and so on and so forth. And then whatever you do, you don't want to defund sanitation and maintenance, and you don't want to defund food safety monitoring. These are all tools in that Listeria equation and pathogen equation that need to be followed and used to your advantage. Next slide, please. So I just have a series of pictures here that help articulate this point. And a couple of things I wanted to point out on this one. If you look at that vent up on the left-hand side, it looks like there's water stains coming down that wall. And every time I've been involved in a low moisture food environment where water enters the building, there's a high chance for salmonella or other such organisms, E.B. Cronobacter, to develop because you've added moisture. Next slide, please. Here's a close-up of that picture under that, but you can see the water staining. And as you look critically think the risk in a room and you see something like that, it should be investigated. Next slide. Here's another example of water or liquid entering the environment that could cause a problem. It's just a joint, a seal, triclover clamp that is leaking because it hasn't been maintained properly. And that's the type of thing we need to make sure that we watch and take care of. Next slide. Here's an example, and this is something that is very hard to see. You have to get in and take pictures of it, but the underside of pump stands, of equipment that have a tendency to collect ricochets of water when cleaning does take place. And that water is absorbed in some of the solid food material that may be in that area. And then you have a resident moist environment that is perfect for growth. Next slide. Here's one where we have a tiled floor and someone dropped a valve fitting on this floor. And when I walked over this floor, it actually gushed, but otherwise you would think it's a tight floor. But there's a gusher underneath when you have a breakage or a crack in a dairy tile floor. Next slide, please. Here's another one of interest, and I think of this when I think of wet foot baths. Here is as you enter into that controlled area behind that quick open door, you can see the water on the tire tracks that are left from a truck that went into that room. And maybe there's a foamer on the other side of that door that allows moisture to be transferred. Anytime you have moisture in an environment, it ends up being a risk. And even if it's a footprint, you're aiding and abetting the growth of bacteria that you really don't want in a food plant environment. Next slide. Here's another one, a classic sandwich joint. Moisture will collect underneath this stainless steel equipment leg, and it's never going to dry out. If you want to look for Listeria or other pathogens, that would be a great place to do it. Just jack that up and sponge underneath it, and you might find something. Next slide, please. Here's another one that looks much better. It's a much better design, but still there's a gap there. And you can see water to the right of that has collected. That could be another risk and allow bacteria to grow. It's another irrigation effect. I'm not sure if it came from that leg or it's a hollow leg or leakage, but anything like that, critically think and critically address. Next slide. Here's another one with electric boxes that have a tendency to leak. And when we clean them as sanitors, oftentimes these boxes are not sealed and they need to get in and be part of the environment. Again, it's not the floor, silly, or Sam, or stupid. It's the things that drip onto the floor that then cause a lot of spreading of bacteria in a plant environment. Next slide. Here's another example of that same thing. And this is one thing that PureLine has that is really helpful. They have a small chlorine dioxide tablet that you can put inside and let and release. And that does help once it's dried to thoroughly clean and sanitize the inside of an electric panel. Next slide. More drains. And obviously you can see there's a collection point for moisture in that drain. It should be a dry environment, but even around the edges of that drain of a lip, there seems to be an harborage area, sandwich joint for moisture, which is another great opportunity for growth. And also rusty surfaces tend to be more porous or have more roughness than a stainless steel smooth surface. So that would be a risk as well. Next slide. Here's another classic drain. You can see that the plates on this are welded in place with stitch welding, which is not desirable. These end up being a real challenge in any type of plant, whether it's a dairy plant or a meat plant or a produce plant. But somehow we have to get in and clean those areas to minimize risk to our product. Remember, anything in an environment during cleaning could be, wet cleaning especially, could be aerosolized and then become airborne and take 4 to 6 hours, 2 hours, depending upon the airflow, for that particle, those aerosolized particles, to settle down on the floor and or onto a product contact surface. So a very high risk area. So another drain, much better in design than what we have previously looked at. Next slide. This is my last slide. And one of the things that we've moved to in the dairy industry, especially and also in produce and also in meat, is to try to use dry sanitizers versus wet. I talked about the footprints that you can see. If you go through a wet foot bath, you can see your footprints for 10 or 15 feet in that dry environment. So we really encourage the use of either an alkaline peroxide powder or some type of quat powder to minimize that risk. And there's a lot of plants that have used that very effectively. And really that alkaline peroxide works really great, as does quat, but there are some other techniques rather than foams and liquid sanitizers that should be looked at. Next slide, I think that's my last one. Okay, Monty, turn it over to you. Thank you.
All right, thank you, Joe, and thank you, Martin, for all the background information. That was great lead into what I want to talk about here, Joe. Next slide. So just kind of, we were going to talk about quickly about environmental monitoring. That's the key to validating that you're ahead of the battle here. And just there's another example of the pathogen control equation that we do teach. The DMI, the Dairy Management Inc. that Joe mentioned, we do workshops based upon that pathogen control manual that was put together. Joe led those, like he said, and we have subject matter experts from the dairy industry that help lead that. But we have participants from across a lot of industries that come, and so I just want to, that's my shameless plug, Martin. So if you're interested in learning more, that's a great way to go and learn from other people who are struggling with the same things you might be struggling with. But returning to environmental monitoring, the reason we do this, and it's the last item on our equation, is that environmental monitoring is what we use to verify and validate that all those other control programs are working the way you want. So first you have to verify that the programs you've put in place are being implemented. Then you validate that they're the efficacy, and we do that through environmental monitoring and swabbing for microorganisms like Martin was mentioning. Big key is hygienic zoning, which Joe just went over. And a big part of that is controlling the floors, wheel traffic, the floor conditions. That's how the bacteria gets in. And believe me, in dry cleaning, as Joe mentioned, the battle is won by not letting it get into the plant in the first place. And so the two key things are hygienic zoning and sanitary design, but also on hygienic zoning that goes hands in hand with GMPs, right? Your employees are critical in this. They need to understand that and make sure that they're following all the procedures that you put in place, all the good manufacturing practices. People are probably the main vector for Cronobacter getting into the plant. You know, we think about salmonella related to Cronobacter business, and salmonella we often think about being transmitted through birds. As Martin said, we're just learning now a lot about Cronobacter, and so we're not really 100% sure all the vectors for Cronobacter, but certainly people are one. Sanitary design is, as Joe mentioned, and shows some great examples of some issues with in some different plants, is critical. So you got to pay attention to the facility and the equipment both. So you got sandwich joints and things you got to worry about, making sure that you minimize all those things. You got to make sure your facility is completely sealed up. Again, air is a great transmitter or a way for moving bacteria around, and with Cronobacter, we have seen anyway that the you got to have your facility completely sealed up. It's it's going to get in, it's ubiquitous, and it's outside. We don't want it inside. So you got to have all these prerequisites to the pathogen control in place. And if you're going to be successful, and then your environmental monitoring is just to make sure that that happens. And part of this is switching to dry sanitation, and that was really what we stressed when we started developing our dry dairy plant food safety workshops, is that we have to switch to dry sanitation. So we're going to spend some time talking about that. But finishing up on environmental monitoring, if we go to the next slide. What we're concerned about, of course, is Cronobacter in this conversation, but also Salmonella. And the reason those are our pathogens of concern for dry environments is those bacteria have adapted to the environment. So they survive, as Martin said, they survive very dry, desiccated conditions. They also survive very well in hot conditions. So hot, dry conditions, they're going to actually go into a dormant state, and they wait, and then when they have the conditions that are correct for them to grow, they'll grow, they'll outcompete other bacteria, because other bacteria aren't adapted to that, and they'll die off and or won't compete as quickly when given the opportunity to grow. And so that's why they're a big concern in dry, and of course because they're pathogens, because they cause the illness. But looking for just Salmonella or just Cronobacter, sometimes that can be I mean, you got to look for those, but that can sometimes be a narrowing effect. And so we use indicator organisms. And as Martin said, both Salmonella and Cronobacter are members of the EB family. And so using EB swabs is a good way to monitor your environment. And so if you look for the larger family of EB, you'll know that you have conditions where bacteria can grow if you get positives, but also, in a dry environment, if you're truly drying everything out and truly doing all the things you need to do to keep an environment dry, the likelihood of those EB that you're picking up being Cronobacter or Salmonella goes way up. So using EB as a part of your environmental monitoring program is highly recommended. And the other thing about your environmental monitoring program is you want to find it. You kind of want to find some things, right? Because what you want to do is you want to seek and destroy. So you want to know where the weaknesses are in all those programs that we put in place. Where's the weakness where we're tracking stuff in through foot traffic or floor conditions? Where's the weakness where maybe something's coming in through the HVAC or other methods? And so you want to have a program where you're swabbing regularly and in regular spots, but also seek and destroy. And so if you have good control at one axis into your packaging room, for instance, but maybe you're still getting noise over around where you're bringing materials in, maybe you have a buffer room where you bring stuff in, and that's where you maybe need to do more of your monitoring. So you need to think about the entire environment and where you need to swab and where you want to monitor, because you don't want just to be complacent and thinking that you have everything under control. It's all about continuous improvement, right? We always have to try and get better and make all of our programs better. And that's how you use the environmental program. You follow the data, you follow your swab results, and you try to improve all your other programs. Next slide, next swab. So dry sanitation is the key to winning the battle. So we say we want to have a war on water. We want to eliminate water. And why? Why do we say that? Because any introduction of the water is going to play into the hands of Cronobacter and Salmonella, right? They dry out, they desiccate, they survive, and they just wait for that next introduction of water. And so a couple of those slides that Joe showed were great illustrations that if you're doing a weekly cleaning, for instance, in a room, or at some point you're coming in at some frequency and doing a wet clean, you're really playing into the hands of both Cronobacter and Salmonella. So that picture with the scum that was underneath the equipment that had gotten blasted up from the floor with water and had coated the bottom of that tank, that's a great spot for Salmonella and Cronobacter, because they're going to lay around in that scum and wait for the next introduction of water. Then they're going to outcompete, they're going to grow, and then they'll spread out throughout the environment. And that's why we want to go completely to dry. And we showed a lot of drain photos there, and drains are a great source of contamination. But in a lot of packaging, dry powder packaging, right, we don't even have drains. So dry sanitation is the way to go, because you can't even introduce water into those places. And the reason we do that, of course, is we want to eliminate the water. So how do we remove the food sources without using water? We rely on vacuum cleaners, right? That should be our preferred tool. We use vacuum cleaners because they have the ability to contain the soils as we pick them up, right? So you want to make sure your HEPA filtered vacuum cleaners, make sure they're explosion proof. You need that sort of a thing. So there's some safety issues to worry about. But vacuum cleaners are also great because they now become our drain. And so that's the thing with wet cleaning, right, is you can monitor the environment with your drains and kind of know what's happening in that surrounding area, everything that leads into the drain. With vacuum cleaners, you can test the contents of the vacuum cleaner. If you have a vacuum cleaner that's dedicated to a certain area, which is what was recommended, then you know that you're picking something up in that area. If you test the contents and get a positive, you know you got to look in that particular area where that vacuum cleaner was used. So we use a vacuum cleaner in environmental monitoring, just like a drain in a wet cleaning area. And vacuums are again the preferred tool because they will suck the soils up and contain the soils instead of moving the soils into those niches and those sandwich joints like Joe illustrated with some of his photos there. The key is to minimize food and environment, right? So we have a key of not tracking the bacteria in the first place. And then the second key or third key, the second key being no water. And then the third key, keeping the food out of the environment. So like Joe was saying with his illustration of feeding the masses, as soon as that food is out there and available to the bacteria, and since the bacteria become active with a little bit of water, now you got growth. And so we want to try and minimize the food, completely eliminate the water. And that's how dry sanitation works. We actually, bacteria dies off, and eventually, even though Salmonella and Cronobacter are adapted to that sort of environment, they too will eventually die out, but they do survive a long time. And that's why Cronobacter is such a difficult bacteria to deal with, because it is even better adapted than Salmonella. It's like Salmonella to a much higher degree. And so we also have to take all of our sanitation programs and our environmental control programs to that next level as well, because Cronobacter is just so well adapted. As Joe, so use of scouring and scraping, I put that down there, and that's because, you know, vacuuming will suck it up, but sometimes you got hard soils that are hard to get up, and even biofilms, right? And so how do you address those? Biofilms are removed primarily by scrubbing, right? And so using that alkaline peroxide or quartz crystals even that Joe mentioned as a dry foot treatment or wheel treatment, you can use that same powder as a scouring method and brush that into, say for instance, you know, a walkway where maybe you're getting some noise. You can scour that surface in a dry manner instead of wet cleaning, instead of introducing moisture into the environment. Just a little tip. But the key is we have to keep the environment clean. So as Joe mentioned, you know, we deal primarily with pasteurization. And so in the dairy industry, we're talking about post-pasteurization contamination is where we're focused. Some manufacturers out there may not even have the benefit of pasteurization, of a heat treatment, of killing bacteria. And so you have to be even extra cautious of keeping the environment out of the product. So that's the key. You want to keep the product out of the environment to begin with. Don't put food in the environment, but then also keep the environment out of the product. So you really got to pay attention to those interventions into your closed system. And in the dairy industry, we have pipes and everything is enclosed, but sometimes we have to get in and check, you know, for product sampling or magnet checks or things like that. The key then is don't introduce the environment into that closed system. And the other key is if the environment is clean, then you won't get it into your system. So keeping the environment microbiologically clean, and then keep the environment out of your product. Those are the keys. And you do that by dry cleaning. And dry cleaning, even though you're not using water, not using chemicals, it still has to have a defined process, right? You need to have an SOP, you need to have a master sanitation schedule. Everything has to be listed out, and it's probably even more important because you have to have documentation that you're actually doing the things that you need to do to clean your environment. The other thing with dry cleaning, of course, is it has to be 24/7. Oftentimes with sanitation, we think we have a 4-hour window, we're going to get it done in this period of time. We want to work on the environment 24/7 in a dry clean only environment. Don't let powder build up or food build up in the environment, and certainly always look for intrusions of water. So next slide. That's like the key, right? We cannot mix wet cleaning and dry cleaning. And so you have to have a good barriers put up. You have to have those transition zones, and you have to look for those water intrusions like Joe showed the example of. So we have wet cleaning on one side of a wall maybe, and somehow we're getting water into our non-wet cleaning area. And that's a recipe for disaster there. Another thing to consider is a lot of people try these modified wet cleaning using alcohol wipes. There's a time and a place for alcohol wipes, but alcohol wipes also have water. And so as they evaporate, you're going to introduce some water into the air. If you don't have good air control, good humidity control, you can get condensation, the water can fall back out. Once the alcohol is gone, you got water. And that's true of our conventional cleaning chemicals, and that's why we don't use those. Even wet sanitizers are over 99% water, and so once the active ingredient in your sanitizer is used up, all you have is the water. So that's why we don't use. We just don't wet clean in dry environments as much as we possibly can. And the key, and then Martin mentioned this, and I think Joe did too, is you got to dry it out. If you introduce any type of moisture, whether it's alcohol or water, it's got to get 100% dried out. We also want to make sure that we're dry cleaning first before you introduce any water. And you probably have seen this if you use alcohol wipe and you haven't done some dry cleaning first, you're going to leave behind a sticky mess, right? You're going to get crustiness. You have to dry clean first before you try any type of modified wet clean or these deeper dives or clean breaks. Sometimes you do have to do a wet clean in a dry area that you're normally keeping dry. You have to do a dry clean first. Don't leave behind soils that are going to get wetted and left behind and become those food sources and those harborages for the bacteria. Then after you do a clean break type deep dive or big cleaning, you got to get it dried out. So you always have to have plan and time and procedures to ensure you have a dry environment once you're done. And we talked a little bit about the wet sanitizers. So how do you sanitize if we don't have a wet sanitizer? Are there any dry clean sanitizers out there? Alcohol wipes are one for sure. And so, there's a timing and place, like I said. So alcohol can be used for high touch areas, HMI screens, tables where you're handling samples, all those sorts of things, but you got to make sure it dries out. And then another tool that we use is the chlorine dioxide gas because it's dry. And Joe mentioned that in J boxes and things like that. It's a great place to put it, one of those little pucks. But you can use the bigger chlorine dioxide or have a full plant treatment if you have to do a remediation. And the nice thing is, you got to clean. You got to clean first because the chlorine dioxide gas has got to get to the bacteria to be able to be effective. And a coating of powder can sometimes be enough to hide something. So dry cleaning is the key no matter what. And if you dry clean properly and we're not introducing any water and all the bacteria are going to die out anyway, you don't need to sanitize very often. You just got to make sure that when you do sanitize, you're using the right tools. And I will say this, if you're going to use chlorine dioxide, you got to have a professional working with you. There are safety issues, concerns with that, but just a tip of the hat to PureLine for that as a close out the discussion on dry cleaning. So that's all I had for dry cleaning, but we'll field questions now, I think.
Okay, well, first, thank you, Martin, Joe, and Monty. That was great. Just want to make sure there's nothing more to add before we turn it over to questions. I don't know if you guys had anything else you wanted to add. Okay, if nothing else, let's turn it over to the attendees for questions. We got over a dozen questions, so that's great. I also want to mention one of the questions was, will this webinar be recorded and emailed out upon request? Yes, it will. So just email me and I'm happy to share the webinar with anyone that wants it. Okay, let's hop into questions here. The first, and I'll read them off anonymously just to keep that anonymous. How to verify that the surface is dry enough after swabbing?
Well, I'll take that to kind of start with. It's a tough one. No, there are dry swabs, so you can try dry swabs. There are methods and different ways to do things. Lots of swabs are wet swabs, and we use wet swabs. And so what we will try to do is we'll make sure we do a good dry cleaning first. Like I said, before we introduce any moisture, we don't want any food sources there that might get wetted. We'll do our swab, and then we will wipe that area down with alcohol wipe and use the alcohol to help promote evaporation. And so the key is you got to make sure it gets dried. So also you can after you swab pre-wipe, just like you would do for dry cleaning, wipe down with a dry wipe first. And so you can dry out with a towel, remove as much excess moisture as you can, and then do alcohol wipe as an evaporative tool. But then of course alcohol also does a little bit of sanitizing as well.
Thanks, Monty. Next question, is Cronobacter a concern in acidified foods?
So just to sort of reiterate, it is a concern in foods and for infants, particularly of young age. So don't know enough about feeding babies to know how much acidified foods are fed to them. But there are some papers out there that can grow up to a pH of 4.5, which would qualify as an acidified food. Could probably even survive it, and could definitely survive at those temperatures. You know, there's some. So just because it's acidified, particularly if the pH is close to 4.6, would not mean it makes it a zero risk. I would still want to have some controls in that, unless you can validate somehow that it dies off.
Okay, great. Thank you, Martin. What kind of sponge swab do you recommend for EB monitoring? We use a quick swab right now, but are looking into switching to a sponge swab. We have so many different ingredients in our facility. It almost seems like we have some interaction of EB testing ingredients not agreeing with each other.
I'm not quite sure about the comment of why they would not agree with each other. Whether that means there's a false positives or false negatives. I mean, I think it depends on the surface. You know, if it's of a large surface, and in some cases you want a large surface, the quick swabs are just not enough. I would go for a sponge. If it's small surfaces, difficult to reach areas, often the quick swabs are better. I think it's use all tools. I think for environmental monitoring, it's not just use one or the other. That's my general recommendation, but would love to hear Monty's and Joe's comments on that.
Yeah, I mean, you really want to know if it's there or not. So it's qualitative, and the larger the area that you can sample, the better off you're going to be. And I like Monty's idea about wiping down the surface with something dry to minimize the amount of soil that might be there or product, and then go ahead and use a sponge. And then after that, then do something with alcohol just to minimize potential for cross-contamination and idle moisture on the surface. And Monty brought up another point. You know, one of the concerns is just the amount of humidity in the air that ends up being supportive of microbial growth and also taking products. So any moisture you have in the environment is going to vaporize and become airborne and part of the environment. So we want to minimize that as well.
Great. Next question. What is the recommended frequency of swabbing sites in a robust EMP targeting EB and Cronobacter?
Well, we do daily swabs, and they're usually on a rotating basis, but sites where we think we've seen issues or where we know we've seen issues in the past will be on a more frequent basis, maybe even daily. But we typically, will have a rotating map that we go through. And so maybe there's some sites that are monthly that we get on a 4-week cycle would only be swabbed during one of those weekly periods. And so you build your plan, but it's all about risk assessment, right? And you got to decide where you're going to monitor, and then follow the data. If you're getting a lot of noise, you need to monitor all the time. If you're not, then maybe you need to go look somewhere else. So I mean, that's kind of my philosophy. But Joe and Martin, go ahead.
I would agree. I mean, infant formula I'll probably do daily. I mean, if some lower risk, maybe, or you really have some other evidence or that you're under control, it could be weekly, but nothing less frequent than weekly. But in most cases, I would think daily.
Yeah, and the other thing I would just add to that, I agree with that. But there's a lot of things that happen during different shifts. So we recommend that you alternate shifts and do swabbing at different times and different days of the week. So you get a full picture, not just what happens between, every Monday between 8 and 10, or every Friday between 2 and 4. So you really want to get a total profile, because that plant environment can be active any hour of the day, and you want to get a good representation from different circumstances and different time periods.
Okay, thank you. How to perform dry cleaning of environments which are difficult to reach, such as buttons on equipment?
Well, so you should have a tear down schedule for things that are hard to reach from that aspect. If they're hard to reach because they're just inaccessible, you want to work in conjunction probably with your maintenance department when they're doing PMs and they're taking things apart. You want to make sure you're going in there and doing the detailed cleaning that's necessary. The other thing, whenever you have maintenance people in there, you always want to clean up after the maintenance people anyway. So make sure that you're working hand in hand with them on those types of things. If you're talking about hard to reach because of ceiling heights, lots of powder areas, have the bins that are very tall, and sometimes you got lots of infrastructure. And so this is where it becomes important to have periodic infrastructure cleaning plans or periodic equipment cleaning plans in place, so that it's probably not something you do daily, but you have to have a plan for getting in there and cleaning it. That's kind of what my his experience has been. And Joe, I know you have thoughts on that for sure.
Yeah, I mean, I think that's a great question, because if you look at some of the dairy plants and the height of dryers and all the equipment that is elevated, it's really a challenge to clean. And I always like to think of a coordinated approach between maintenance work and sanitation work that you can schedule on a annual basis, maybe a 52-week schedule that you look at and say, okay, once a quarter we'll do this area, and then once a quarter maintenance also would go in before us, and we would be there to clean after them, and then also to clean the general environment. But I think it really is a challenge to get some of those hard to reach areas clean. And they could be equivalent to the floor in terms of risk. So yeah, I mean, that is something that needs to be a high focus, and due diligence needs to be into every square inch of that plant.
Thanks, guys. The next two questions are kind of related to each other. So what are your thoughts on the ability of Cronobacter to develop some level of heat resistance through repeat exposure or development of biofilms?
I would say it does potentially, but I think it's mainly of academic relevance. I don't think it's at a level where you're going to have to change your monitoring programs to be concerned about it. It shouldn't build up that much biofilm anyway. So interesting research question, but practically speaking, I think no, I wouldn't worry about it.
Okay. Let's see here. Next one. Have quartz crystals been used to scour niche points? What if crystals cannot be removed from the niche points?
Well, the crystals aren't going to be nourishing, right? So it's not like you're having food. Yes, they've been used for scouring. I think alkaline peroxide might be a better option, just because the quartz crystals really require moisture to activate. You got to get the quad into a solution, and then it does its killing. And there's theories out there about whether there's enough moisture in a biofilm or moisture in a single cell, or whether it activates or not. It's probably more likely with alkaline peroxide just because it activates immediately. It kills on contact and gets used up on contact with water. So the quat, has a residual effect, and so that's kind of a nice thing. I think it's definitely something you got to be concerned about. And I would say, if you're pushing quat crystals into a niche and leaving it behind, you're probably also pushing food into those niches and leaving it behind too. So you got to figure out a way to tear that apart and then deep clean it at some point.
Thanks, Monty. Next question. Any recommendations for keeping the environment out of the system when we are dumping bags into a dump tank? We just do dry powder blending, mostly dairy, not infant formula. Current process is they are set on the ledge of a dump tank, cut open, and then dumped into the tank through grates. The bag usually sits on the grates as they are dumped into the system.
Yeah, well, I mean, I've seen that obviously, and it's not a not a very sterile environment, obviously. So I think the couple of things, you want to make sure that you're got good dust collection, so that you're not building up a lot of dust in the environment. Again, it's tough to keep the whatever contents might be on the outside of the bag is going to be a concern when you're dumping it over your hopper. There's definitely a risk there that you're introducing something from a microbial standpoint, but what you hope is that it doesn't ever find a spot where it can grow and survive and live, right? So no moisture, make sure you're not getting any moisture in there, or if you do, you got to dry it out completely. The key is to keep the environment as clean as you can, so that you don't have you're open to the environment there, so you got to make sure your environment's clean. I don't know, Joe, what do you think?
I mean, yeah, it's a challenge. I would like to think there's some automation they may be able to solve that problem with, and switching over to totes would be a better alternative with some type of conveyance into the mixer. Because I see that from a micro problem, cross-contamination problem, because those bags should all be stripped. And also you have potential for allergens that could disseminated through the air in the environment. So yeah, I'd suggest try to go to tote deliveries and have them set up that way, because once that dust gets around, it's a mess for housekeeping. It's microbial risk and an allergen risk.
Yeah, no, it's definitely. If you're making products that are Cronobacter sensitive, you probably want to get away from any type of bag dumping. I mean, hopefully that's happening pre-pasteurization, so you have some sort of heat kill and you're blending. But if you're just dry blending and going into a finished product, you're probably, you're setting yourself up for failure if you have Cronobacter problems or products that need Cronobacter specification.
Thanks, guys. The next question. Published studies indicate that there's a wide variation in the rates at which Cronobacter are detected in powdered infant formula retail samples. And one group of researchers speculated that a higher rates in some studies might be attributed to more accurate detection techniques. Comments?
Yeah, that could definitely be the case. I mean, it could even be, without digging deep into the details, it could even be the high rates of false positives. There are PCR assays out there that give you positives with dead DNA, and that seems to be a case sometimes in infant formula. So could be true differences, could be methodological. And I have the other question that I can just,
okay.
The second question is detection methods. Recommend 10-gram samples from a can of 1 kilogram, and then you composite them. Typically, you test at least 375-gram samples. The comment is Cronobacter is distributed heterogeneously, and therefore any sample size calculations that assume random distribution or normal distributions don't work. Absolutely correct. Someone is interested in it. I have a colleague at University of Illinois who's developing sampling plans for heterogeneous, developing methods how to design sampling plans, assume heterogeneous distribution specifically for Cronobacter. So people are working on that, and it's definitely an issue. And then the second question was preparing powdered infant formula water heated to 7C, take boiling water, cool it for 30 minutes. Oh yeah, so obviously, you know, but the cooling for 30 minutes takes boiling water to 70 degrees centigrade, depends on a lot of factors, ambient temperature, size, surface area, etc. You would have to at least verify that with a thermometer. This is somewhat of a hot topic because there's word out there that people say infant formula manufacturers should put warnings on. They say you should have prepared with hot water. The problem is if you do, you know, how many babies are gonna get their hands on a bottle that's boiling hot, and then you have issues other than Cronobacter. So it's not the magic bullet. Preparation with hot water, and people think it's a classic case of, you know, unintended consequences potentially.
Okay. The next question, I think I can take. What are the main safety concerns using chlorine dioxide and how to overcome those? So the only time the customer or the food plant would be doing the chlorine dioxide is using the Pure Vista, which is in the middle of the screen here. Those are the water activated CO2 gas separation products. Typically, we will be contracted to come out and do the first treatment, and we will do hands-on training. We have a number of customers and you know, food companies that do this on their own after they receive training with the proper PPE. You just want to make sure you can safely contain the gas and you have a safe way to vent the gas. Anything larger, if we're doing, you know, your half your plant, your full plant treatments, that's a service we do that, you know, we evacuate the plant, and then it's usually an 8 to 12 hour treatment, depending on how big the plant is. But there's no residual post-treatment. So hopefully that answered that question. And then the next one, do we prefer wet swab in zone product contact area for CB and salmonella?
Well, I think we talked about it. The challenge with wet swabs is you introduce moisture. If you do, you need to make sure you dry it off. You know, need to verify that as good as you can, probably with visual verification.
Okay. What are your thoughts on recent recall in RTD beverages?
Yeah, I just looked that up. So these were, the problem was it was sort of looked like a Cronobacter recall, but in reality it was that these were RTD that should have been, you know, sterilely filled, and they weren't. And that's why Cronobacter. It just happens that they found Cronobacter, but I think it wasn't a Cronobacter specific recall as much as one that is just a failure to properly process. I mean, obviously, if you have RTD products that may be fed to infants, you have an issue very specifically. But in these cases, any organism that's there indicates your process didn't work right, and you have to recall. I don't know if anyone else wants to add something to it.
Yeah, I think there were some adult nutritional type beverages maybe that were made in the same lot, and they probably had a spec for Cronobacter and they got caught that way. But yeah, I mean, Martin's point is exactly right. I mean, it's supposed to be an aseptic package, and it obviously wasn't, so they had a failure in the process somewhere.
Thank you. Is it possible an uncontaminated milk powder already packed gets contaminated by Cronobacter in the storage due to high humidity in the storeroom?
I would think that would be unlikely. I mean, anything can happen if the package is damaged, but if the package was properly done, sealed, I would think it would be highly unlikely.
Agreed.
Okay. How effective is chlorine dioxide to kill and control biofilms? We actually did a study. Montana State University has a biofilm department, and we reached an 8-log kill on, or 8-log biofilm kill to show no detectable life after one of our treatments. So it, and actually, funny, when we do plant treatments and stuff, depending on the organic makeup of the biofilm, when it's oxidized, it'll, depending on if it's a sugar-based biofilm or flour or whatever, it'll illuminate it and turn it a different color. It can be like a rust-colored orange or a pinkish color, but it'll help maybe illuminate maybe where some mist surfaces are during sanitation too. So, next question: does the same swab sample can be with EB negative and Cronobacter positive. I'm not sure I understand that. You guys?
Well, the question is can you get if you did the same swab and you did EB and it came back negative, but you also did a Cronobacter and came out positive, is it possible? Well, it kind of is, because it just depends on whether with the sample that you're splitting, are you actually picking it up on the EB film or not? I don't know, Martin, that's much more in your field for sure.
Yeah, I mean, the devil's in the details. So if you're taking a single sponge and doing a single enrichment and then go into Cronobacter and EB, I think it's theoretically possible. But if you do enrichment for both, then you wouldn't expect it. I'm sure everyone it can happen, right? We can conjure up these rare situations. I mean, Monty's point is a really important one. If you take two sponges from the same site, and you think what's the same site, yes, absolutely, one can be positive and one can be negative. We've done this with Listeria in about 60% of the cases. We take two sponges, same site, one is positive, one is negative, because it's at low level, not both sponges pick it up. So if it's a single enrichment, much less likely.
Okay, thank you. Next question. Have you seen a difference between quick swab and sponge in the EB recovery?
We haven't done any work on that. I don't know. I mean, I think recovery is a tough one, right? I mean, because recovery to me might imply how well we get it off the sponge when it's on it. So to me, you know, when you select sponges, there's multiple considerations. I wouldn't just boil it down to one simple thing like this. It's like, what surface area can you swab? How likely is it to be picked up? And then how likely, once it is picked up, is it to be detected? And that could be after enrichment, or if you try to just stomach and then do a quantitative method. I'm not aware of any studies that have done these comparisons. It's probably something to ask the people who make the sponges, if 3M or someone like that has data, but I haven't seen any.
Okay, next question. Dry sanitizers in high traffic areas like Hyster, do you see a lot of powder spread about and, you know, made to look messy, i.e. questionable, just from the stance have you seen better alternatives?
Yeah, I mean, I can answer that one. Dry sanitizers do have a tendency to look messy. It's just the nature of the beast. When you put something on the floor, it's going to be spread around. There's also an advantage to that, in that when you see, especially with alkaline peroxide, it's less granular than quat, but you'll see that on the floor, and you'll see a white floor versus a typical concrete floor. And sometimes with quat, if it's overused and spread heavily, it'll be taken throughout the plant and the offices and the carpets. So I think you have to be strategic in its use and follow instructions. Shouldn't need that much in a dry environment. So just be cautious about how much you use and follow the labeled directions. But it will be noticeable on the floor.
Thanks, Joe. What level of concern what level is the concern on EB?
Wow.
Go
ahead,
you have to jump
No,
off.
I was just going to say, if you have EB, then you have conditions that are capable, you know, where it's capable for Cronobacter or Salmonella. So it's an indicator of the organism. And if you're getting positive EBs, you could be getting Salmonella or Cronobacter, because they're part of that family, right? Sorry, Martin, I jumped on you.
No, but it also hugely depends on where you sample, right? I mean, if you were to sample, not I recommend it's a zone 4 or a zone 3, you know, you might be okay with, your limit might be less than 10, which is basically the detection limit of some of your quantitative methods. If you do a zone 1, you probably will do an enrichment potentially then. And so, but in most cases, yeah, any detection would be cause for corrective action, at least, I would say. But you can also adjust that by obviously, you know, the sensitivity of your method and the amount you swab, right? I mean, you know, like you have 5 colonies positive on a big sponge versus like negative on a small swab, essentially probably going to be the same. So you got to, again, take all of this in consideration. But I think in most cases, any detection, corrective actions. In some cases, you might work towards more continuous improvement, where for a while you say, okay, if it's less than 20, it's okay, then less than 10, then negative, then bigger sponges in less than 10, and then negative after enrichment, and you drive it through continuous improvement. But I think if you're not talking infant formula facilities, so I'm always worried that some people who come from some completely different facilities, then the story might also be slightly different, right? So, okay. I'm going to have to jump off, everyone, but if someone needs something specifically from me, you can email me at mw16@cornell.edu. I'll take the questions. Thank you.
Thanks, Martin.
Thanks, Martin.
Joe, Monty, we just have a couple more, handful more questions if you guys have a couple more minutes.
Yeah, I really need to drop off as well. So,
Okay.
yeah. So thanks for the invitation, Jared, and good to see you, Monty.
Good to see you too.
Other folks have questions. It's my email address is joe.stout@cf-san.com. Thank you. Bye now.
Yeah, maybe we can provide written answers to the remaining questions or something like that.
I think that's a good idea, Monty.
Yeah.
Okay. All right, everyone. Well, thank you so much for joining us, Monty. Thank you very much. And I think that concludes the Cronobacter, the Food Safety Roundtable, Combating Cronobacter for today. Thank you all very much.
Thanks, everybody.